Hey everyone, this is Matt with Learn Everything About Design, and in today's video we're going to do part 2 of our adjustable kickstand series. Now, in the first video, what we did is we scanned the kickstand off of my KTM 450. Now, as mentioned in that video, this is an aftermarket kickstand because the bike is an SXF, basically a motocross version that doesn't have a kickstand by default, but mine is titled and street legal, so I need to have one. And so this is the only one available, but a couple of problems. My bike is an X-Race bike. It's had the rear shock, the internals changed, so it's a little bit lower in the back. And that one presents a problem because the bike sits too straight up and down. The second problem is I'm running dual sport tires. I also have supermoto rims for it. And so I really need something that can not only take care of it when it's got dirt rims on it, but also when it has sort of lower profile dual sport tires or even the 17-inch supermotos. And so what we're doing is we're basically going to be cutting off the end of the existing kickstand, and I'm going to be recreating this bottom piece, but I want it to be able to slot up and down to two different positions. So I'm going to essentially drill and tap inside of the current slot there, and I'll create a machined piece or two pieces that will screw together and offer stability, but give me the ability to essentially adjust that. And so with this kickstand, it is just raw bar stock that has been machined and then bent after the fact. So we really can't go up past the bend here. And also the little pad on the bottom being offset backwards means that when the kickstand swings up, it hits the number plate on the side. And so in the newer version that we're going to be creating, which I haven't done yet, that is going to be centered or at least shifted forward, so that way it doesn't hit the bodywork. And then again, it's probably going to be, thinking about manufacture, it's probably going to be two pieces, meaning that there's going to be a front piece with the foot on it, and then there is likely going to be a back piece for some extra stability. And I could potentially just drill passing holes here and have tapped holes in that back piece. I don't know yet. This is just kind of, in my head right now. So we're going to get through this video. We're going to do all the processing, and then we'll get into the design. So to get started, the first thing that we generally do is, well, in this case, we need to decide, which version of QuickSurface we're using here. Now, we are an affiliate. I'll put all that information in the description of the video, but there are essentially 3 standalone versions of QuickSurface plus an add-in for SolidWorks. And with the standalone versions, we've talked about this before, there is a personal version that offers up a lot of modeling tools, but it only gives you the ability to export an STL file. Now, we are doing machining here, so I do need to design a part that is actually true CAD geometry, not a mesh. And so I could theoretically use QuickSurface LITE, but QuickSurface LITE has limitations with some of the modeling tools, right? We can't use things like combine or cut or intersect. And so we would have to essentially take the mesh directly to Fusion after it's aligned and processed. With a part like this, I find it's going to be easier for me to extract that CAD data as sort of a dumb solid or a BREP, and then take that CAD data as a reference over to Fusion or whatever CAD program that you're going to be using. And so that's kind of why I chose Pro. Now, obviously, these are in very different price brackets and different leagues. So again, you have to decide which software makes the most sense for you. But hopefully in this video, you'll see some of the tools that make Pro, kind of beneficial for this type of thing. All right, so first steps is going to be for us to select the mesh, and then what we're going to do is go to our scan data, and I'm going to reduce the polygons. Now, when I do this, I want to turn on Show Mesh Wireframe and also Keep Original. The original has over 2 million polygons, and when we zoom in here, you can see there is a lot of small polygons in the side. This is pretty typical when we have a really dense mesh come from something like RevoScan that has had some mesh processing done. So things like smoothing and simplification. In RevoScan, when you go through the simplification process, it looks at the angle between triangles and it tries to make larger sections of triangles where it can. Now, the algorithm inside of QuickSurface, QuickSurface Pro, QuickSurface LITE, this one is much better at that. And what I mean by that is I can take this down to 10%, for example, hit preview, and it's going to leave the higher density mesh in those filleted areas in the corners. It's going to smooth things out pretty well. And you'll notice here the tolerance is still within 99.2% of that original scan. And so this is pretty helpful because what this allows us to do is when we start extracting things like lines and slots and so on from the scan data, this means that we have got a much cleaner reference. Now, looking at this part, again, I mentioned that it is essentially just raw bar stock. It's not even like machined on the outside. It's had these slots machined and then it's been bent. And with that, it is not perfect, meaning the fillet sizes, the rounded corners are actually not the same from left to right. And so my guess is they probably took like a fillet tool and just ran it along the edge. And because of the variability in the raw bar stock, it's just, that tool just made a smaller fillet on one side than the other. Because of that, I'm going to try to match the geometry here rather than some like consistent value. And there are some pretty cool tools to do that in QuickSurface Pro. All right, so now that we've got this, I'm going to say, okay, again, keeping the original mesh because it's always good to still have the original in case we want to do something with it. And so now I've got this, we want to start to actually align it to a coordinate system. Now the way that this is set up, basically you can move from left to right. So process the scan data, work on getting your primitives, then align, and then start to extract some sketch data. And from here you can use surface tools, freeform tools, or part design tools, which all have their own sections as well. You can jump over to those sections, but most of it's on the main tab, or most of it that you would use for 99% of operations. And then there are some right-click menu options that you can get to, and some of these have drop-downs, so you can see there are extra things here in some areas, like patterns, for example. All right, first things first, extract primitives. Now there are a lot of tools across the top here. There are really 2 or 3 that are extremely handy. This first one here for segments, I believe, is a QuickSurface Pro only feature. And so when we click on that, it goes through the process of breaking up faces based on some general settings of this slider. And essentially what this slider is doing is it's looking at the angle between triangles. And so the farther up that we put it, the larger that angle is, even though there's no on-screen indication of that. And then as we go down, it's going to make it smaller. What we're using this part for the first section is really just to get the bottom and this front face, which are both flat. And so I'm going to select the bottom. I'm going to create a plane. I'm going to turn on the analysis tool, which is going to let me see the green area, which is where we're plus or minus 0.03 millimeters. You can see the color bar on the right side. And then anywhere that's kind of blue or red, blue is under, red is over. That's because this kickstand has been used. So every time it hits the ground or the bike slides, you put it down and it's on asphalt or concrete, it gets worn a little bit. So because it's not brand new, it's not a nice machine surface, this is totally fine. We're going to select create and stay. This one here, once again, I'm going to do a plane. You'll notice that where it gets close to that bend, it starts to fade away. Create and stay. Next, I'm going to go to the magic wand tool. And so again, this one's curvature based. So if we come over to the side of our part here, I can begin increasing this, which is basically looking at a larger degree between triangles. And once I'm happy with the selection, I can hit the fit plane. Now the trick here is I want to use a constrained option, basically making it perpendicular to plane 1 and then double checking to make sure it's not too far out of alignment. Now the reason for this is because we're going to use these to represent our X, Y, and Z orientations. And so I want to make sure that this plane is going to be perpendicular to the bottom of our part. So I'm going to select create and stay. You can also use other tools like freehand. And for this, you may find you want to zoom in and then just pick an area here. And then again, create a plane. I'm going to make it perpendicular to plane 1 again. You'll notice that it turns red up here, and that's because this is welded and that weld bleeds over that top edge. And we also have chamfers on the top and bottom, and there are some fillets around the side. So in this case, it's okay. I'm going to select create, which will end the extraction tool, and now we've got all these planes. Now the front one here I don't really need right now, so I'm going to hide it. The rest we're going to use for alignment. So we're going to next go to align by coordinate system. First I want to pick plane 1, and if I need to, I can click on, I can click on the orientation of these by selecting flip or by picking, right, front, or top. Now we want Z to be pointing up, basically the orientation of the bike. Next, I want to pick the edge that's going to represent X. This is going to be plane 4. And then I'm going to pick plane 3, and that'll push my coordinate system essentially into the corner, the intersection of all 3 of those planes. I'm going to apply that to everything. There's no imported CAD geometry, but apply to all features, select apply, and then close. And so now if we go to our view cube up in the right-hand side, if we look at this kind of down the part, you can see the angle that we're seeing here for the mounting bracket. That's essentially the angle the bike would be leaning at. And the bottom pad is going to be flat on the ground. This would be essentially the designed angle for how far it is leaned over. All right, so now that we've got all the coordinate system stuff taken care of, really all I need at this point is going to be plane 2 for now. Let's go ahead and zoom back in. Now, the path that we're going to go to model this, I'm going to talk about 2 different options. And essentially what we're going to be doing is I'm going to extract geometry for the slot and generate or create the slot first. And then I'm going to create an extrude for the outside body. There are other ways that we could do this, but because essentially that slot is cut away from that solid body, and there's one on the backside too, what we need to do is we're going to extract it as its own body, and then we'll use tools like trim or cut later on. The second way that we could do this is to create a plane that is cut through the part. Now this is a little bit trickier based on the planes that we generated. We could go through the process of creating some different planes. For right now, I'm going to show that part a little bit later. But essentially what we would do is create a cross section and then extrude it down. Again, because of these slots, the fact that we've got a thin slot on the back and the slots on the front, and again, the fillets on the side are different, and actually the slots are not lined up very well either. So we're going to have all these little variables to deal with. And so the first thing I want to do is select 2D sketch. I'm going to select pick to pick the plane I want, and this would be this one here, and begin pulling it down until I have a good reference for that slot. Once I have it, I'm going to select create. It'll jump into my 2D sketch. I'm going to go ahead and zoom in till we're down here. I can hide the plane. I don't really need to see it. And now we need to start extracting some data. Again, I'm only focused on the slot right now. There are a couple of tools that are Pro only. So for example, Sketch Assist is Pro only. This would allow you to try to automatically extract data from the entire, in this case, mesh section that we created. This is an extremely helpful tool in a lot of cases, but I do also find it very helpful to be able to do this manually with fit primitives. So in here we can, for example, select a slot. And so what we're going to do is I'm going to come down here and we'll just grab all that and then let go. And now we've created the slot for us. I don't know if you guys have this. I have this all the time. I switch between keyboards, and every time I go to hit shift, I hit caps lock. I don't know why that is, but that caps lock is really where I want my shift key to be. All right, so now that we have a slot, this is snapped to the reference, but it is not dimensioned. And so the first thing that I would do in a case like this is I would look at the constraints I have. And so for example, this end point here, I'm going to anchor it. I'm going to lock it down. And then I'm going to go to my dimension tool, and I'm going to go from left to right. Now, I measured this, this slot. It's actually 12.75 millimeters. So 12.76 is relatively close, 0.01 millimeters. Depending on where you create this section sketch, if it's deeper in the slot or if it's higher up in the slot, because we're scanning down into a recess, you may find that it varies a little bit. In this case, what I'm going to do is just put 12.75 and hit enter. Now I'm positively dimensioned it. You didn't really notice any change because the difference between the reference that we got and the actual numbers are pretty close. Now remember, I locked this point down, but I want to create a dimension from one side to the other. And so this distance is 66.88, again, relatively close. It can vary just based on how deep we pulled the sketch into this area. So this is all we need for this point. If you need to dimension to something else, you can. So for example, if you want to go from where we place the coordinate system or the origin up to there, we can. Because that plate is actually at an angle, it's It's not quite as simple. It's leaned backwards in the XY plane as we're looking at it, and obviously it's also leaned backwards in the YZ plane. But in this case, I'm going to just go ahead and leave it at that without adding an extra dimension because I locked that point in place. So from here, we're going to select Extrude. Now, one of the nice things, one of the benefits about using QuickSurface for something like this is as I'm pulling this arrow, let's see if I can get to it. As I'm pulling this, why is it not? Let's go this way. As I'm pulling that arrow up and down, I can hold down Control, and that will snap to the bottom of the part. And we've got these analysis tools that let us see how close we are. Now, for the vast majority of that, you can see that it's green. It's a little blue up here. And again, I use the actual dimension of the slot rather than the sketch reference. You can see it's green down there. You'll notice there is some red variations in these corners. This area right here is pretty red, which means that the scan was likely just a little bit off. Scanning down into slots is tricky. So this is a case where you would want to make sure you use the references that you measure. And so I'm going to select New Solid and OK. And now we've created our first geometry. The next thing for us to do is to create the outside shape. We could also create the slot on the backside, but the outside shape that we want to remove this from. And so this can be done a couple of ways, but again, we're going to start by creating a sketch. We'll pick that same plane. I'm going to pull this down into the middle of the part, and then we're going to create that. And so as we're inside of here, I'm going to go ahead and pull this up. Basically, I don't need anything up past the bend, and really what I want to do is just capture above this slot because that's about how high my part needs to go up. And then we're going to take it down through the bottom of this part. So again, we're going to extract primitives. This time I'm going to do a line. And so I'm going to just kind of grab things over here. On that side, we'll do the same thing over here. On that side, and then we'll say back. And so I'm going to take a line. I'm going to come from here. I'm going to make it perpendicular. I'm going to trim that later. And I'll do the same thing down here, perpendicular, and then we've got a trim tool. So over here we've got trim, and we can basically draw through. I'll zoom in here and draw through that. And we'll do the same thing up here. So basically just hold down the left mouse button and draw through. I'm not too worried about this going into that slot area. Again, everything above that I'm not worried about. I'm not going to mess with past the bend. We're going to be cutting it off down here. Now as far as at the bottom, we can select the modify tool. Go ahead and pull this up and zoom in and drag this down. And it does a really good job of staying snapped to our geometry. And that way we can extrude through, and we'll use that bottom plate to trim it. And so I'm going to select extrude. For the top, again, hold down Control and snap to the top of the part. Rotate around and begin pulling this down. Again, hold down Control and snap to the bottom. You'll notice closer to that bend, we start to get basically further away from the geometry. Again, in this case, I'm not replicating the entire kickstand. I don't need it. So I'm not really too worried about that. So I'm just going to say OK to New Solid. Then we need to create a reference for that back slot. So we're going to do the same thing again, 2D sketch. We're going to pick the plane, which is that. We need to pull down until we get that bottom slot. And again, you want to find your references, create, and then we'll use our extract primitives again. I'm going to use a fit slot. Let's go ahead and zoom in. And go ahead and just drag through this. You'll notice that it is offset. Again, I mentioned that it wasn't really super accurate. And again, I don't really care about this upper part. So what I'm going to do is say back. And as I begin dragging this out, I just want to get the slot portion past the end. I'm not going to worry about dimensioning this one because in reality, again, it's kind of off. But what I want to do is I want to pull this out and then hold down Control and snap to the bottom. Again, it's pretty accurate in the area that we need. And once we get up here where it starts to get into the bend, it starts to get a little off. But I'm going to say New Solid. And now we've got these three solids that we can basically trim things away. Now, there are a couple of tools that we can use to make this happen. If we select two solids, so for example, if I select these two, you'll notice combine is lit up, or it's selectable. Cut is not. And so if we select just this body, notice that now we've got the cut option. We can select cut, pick the body we want to cut away, and say okay, and that'll remove it. And so you have to be kind of mindful of the selection process. Now, if we happen to select both of these bodies, let's go ahead and grab both. We can also use trim to make this happen. And so, for example, if I click on the green area and then this pink area, even though this is kind of like a surface trim tool, it has the ability to deal with the overlapping sections. It'll merge those faces together and it'll create our solid for us. Notice that we have options down here to do things like group faces together. We can show wireframe shapes if we need to, if it's helpful for our selection process. But once we're done, we can say okay, and now we've removed that from the other side. And so again, cut works depending on your selection. Trim also works, and it can work for more than just one group of solids, so like a solid in a tool. Now we need to create the bottom foot and remove that material. So the way that we're going to do this is go back to our planes. Plane 1, create a 2D sketch. Now, because this is automatically using the XY plane, it's the same as the plane that we created. So it's not really going to be any different, but I'm going to go ahead and just pull this up. I want to get a little bit below where the weld starts. And then I can go into Sketch Assist and let's just pick everything. You can see lines, arcs, rectangles, and you can see that it's pulling this out. Now, the big problem here is depending on your mesh reference, you may find that it gets a little out of control in corners. You can also turn off things like circles, slots, and rectangles. And you can redo this with just a spline, for example. Once again, I like to use the extract primitives in many cases because it does provide some benefit. In this case, what I'm going to do is a rectangle, and I'll select everything. It's going to create a rectangle for us, and then I'm going to use this sort of corner trim, and I'm going to use auto fillet and just drag around that corner, drag around this one, drag around this one, and this one, and notice that that's a little bit better. It's not perfect on this side, and so if we have that problem, I'm going to go ahead and just select everything to just show you another way. What we could do is we could fit lines, and so let's say I'll create a line there, one in the bottom, one in the top, and then we go back to that corner treatment, and I just drag around those two, and it'll automatically extend them out to the point where they would intersect, and then it'll create that fillet for us. And so, again, we've got these basically Sketch Assist auto extraction tools. If you've got a really clean reference mesh, like you don't have this noise and junk in the corner that we have, then that can be really quick at pulling out an entire cross-section of a complex mesh. But we also have these extract primitive tools and things like the corner trim, which can make really quick work of it. And so from here, I'm going to extrude. Once again, holding down Control will let you snap to the mesh, make really quick work of this. And you notice that as I move back and forth across, what I can do here is I can find a position where I have the most amount of green. And you might be thinking, why is this so far off? Part of it is going to be based on the plane that we've created, because again, the bottom is not perfect. Another part is likely due to warpage when this was welded. And so the welds on this side could very easily warp this up or warp this section up. And so I'm not too worried about being perfect because again, it's going to be replaced with a machined part. So we're going to say, okay, I'm going to hide the mesh. And then I don't need the plane, I'll hide that. And now I want to create one solid body from this. And so I'll select both of these. And I'm going to use the trim tool and basically just cut away that bottom section and say, okay. And now we've got one solid body. I'm not going to worry about putting the fillet on the bottom because when I take this to Fusion, I'm going to split that off and just shift that plate forward. But the point right now is to get something as close as possible to the scan. Again, not worried about those fillets or, basically the weld beads that are essentially a fillet, but it's not a perfect fillet, so it wouldn't replicate it perfectly anyways. The last thing that this part needs is going to be the fillets on the corner. And this is where it's extremely helpful to have something like QuickSurface. And so, for example, I'm going to turn on analysis. And as I begin to drag this down, notice that the edge is turning blue, green, and yellow. So I can find essentially the perfect spot where I'm getting the most continuous coverage across there. And you can see that's right around 2 millimeters. So we'll create and stay. I'm going to repeat this over here, begin pulling this down. I'll potentially rotate it. And then it looks like this one's a little bit off. You can see that's kind of low. And so what this is telling me is it's not a continuous arc. We do have other profiles. So I can take a look at a conic curve, see how close that is. And I can also take a look at a curvature continuous fillet. And so you can see there's some variability between these. Something that we're going to have to deal with, which unfortunately would make manufacture a little bit of a pain. So what I'm going to do is I'm going to get the best or closest with a circular profile, which is going to be the easiest to machine on the inside. And then if there is any little problems with the final manufactured part, I can always file this down a little bit if needed. But it looks like about a 3 millimeter fillet is going to be where that is. So I'm going to say 3, create and stay. And I'm going to repeat this on the back side here. Go ahead and again pull that in. This one looks a bit better. Looks to be about 2 millimeters again. So we'll say 2. And then we'll do this side over here. So we'll go ahead and pull that down. And again, it looks like it really wants to be about 3. So let's try 3. Apply. And again, I'm not worried about this upper section here because that's where it starts to bend away. I really am more focused on what's happening down here. Looks pretty good until it hits the weld. So I'll say OK to create that. And so now we've got CAD geometry that pretty closely resembles the scan data. Now I say pretty closely. Obviously, it's close enough for what we're doing. If we were going to try to perfectly reverse engineer this, then I would use more measurements for the location of features. So obviously this top one I measured and made sure that it was correct. The back one, we just kind of used it wherever the scan reference was. For the part that I need to fit this, it doesn't have to be a press fit or a tight fit because it's going to essentially use this for a little bit of stability, and then the pieces are going to clamp or screw down. And so that's really all I need to worry about. The other way that we could go about making a part like this, and I'll just show this relatively quickly, and that's going to be to basically create a cross section. And so when we do this, this is a little tricky because there is a small slot that happens here, and then the small slot on the back side. So it's not really a true rectangle. But what we're going to do is we're going to extract that. I'm going to hide the mesh. I'm going to hide the solid body, and we'll zoom in here. And so again, the way that I would do this is likely a straight line here, a straight line there. Probably, I don't have a ton of references here, but maybe there. And then I'm going to go over to there. We'll say OK. And then I will use the corner treatment. See if we can get a fillet that's relatively close. And we'll do those two. This is a bit of a stretch. I'm not sure if it's going to do it. Yep, it did it just fine. There we go. And so again, you can see that this is like 2 millimeters and 2, and that's 3 and 3 because it's just not consistent. It's not like a high precision machined part, which again is why I'm not super stressed about this. And so what we're going to do is now that we've got that profile, let's go ahead and zoom in. Tooltips always are in my way. Then you can pull it down through. And what you're going to see here is that on the side, it looks really good. It's all green. It's all green on there. It's a little blue there. You'll notice at the back and the front, it kind of does not match up. And this is the reason why I didn't choose this direction to go for this part. Now, it's likely due to the fact of where I put that cross section. It's a bit up into where it starts to bend. If I had made that cross section a bit lower, it would be more accurate. But because I knew that this was essentially this is just a raw bar stock part with some not very accurate fillets machined on the outside, That's really why I opted to go the direction I did by creating the slot that's really the most critical feature first, and then creating the outside shape and going from there. Now, I'm not going to worry about adding the chamfers to this bottom plate again. Once I get this in CAD, what I'm going to do is use split body and move that entire plate forward. And then I'm going to create other geometry that would go around what we have here. And so that's why I'm not going the next step of doing things like chamfers. But just to kind of show you this, you can use the chamfer analysis just like we did on the fillet. So for example, you can begin pulling it down. You can see it looks like it's about a 1.5 millimeter, somewhere about 1.5 millimeter for the chamfer. Obviously the weld is in the way, but this is a really nice feature and way that we can make sure that things like our fillets and chamfers are accurate to the scan data, as accurate as your scan data is. So at this point, I need to save this. I haven't saved it at all. That's one of those things where I do what I say, not what I do, right? All right, and then we want to export the solid body. And so in order to do that, with Pro, we have a lot more options. But essentially what we want to do is we want to take the mesh as well as that solid body. And so you can go up to the Q menu and you can say Export Model. And I'm going to call this one Aligned. I'll just put video after it so I know what I did. And then you can pick IGES file or step file. I've covered these in the past. There are some nuanced differences between the way that step and IGES handle multiple faces of a body. And so if you're using something like QuickSurface LITE, I generally will go to the IGES export rather than the step export, but it's just something that you'll have to play around with. And then next I want to export the scan data. Now this, you can come up here or you can right click and you can go to export from here if you want to. And notice it has 10% after it. I'm going to go ahead and put aligned after this as well. And so that's nice because it takes the name here, which includes how much we reduce the polygons. And so now we've got both the mesh data processed, cleaned up, aligned to the coordinate system. We've got the BREP or the dumb solid CAD data. Now inside of QuickSurface, we actually do have history, so we could go back to any of these things like the sketches and fillets and so on and take care of that. But once we export it as an IGES or a step file, all that history is going to be gone. But we've got the saved version inside of QuickSurface if we ever need to come back, add more features. We've got the exported version that will bring into Fusion and we'll begin modeling the actual part that we need to get machined. And so if you have any questions on this process or you want to see more content in QuickSurface, we do have a video planned where we're going to talk about QuickSurface for SolidWorks. I've got a couple of requests to do that, so we've got a project that we're going to do inside of that. Again, if you don't have QuickSurface, they're a little bit hard to follow along, but hopefully it gives you an insight into some of the tools and functionality that are available. Now, any questions on this, please let me know. You can leave a comment. If you are looking to buy, again, we're an affiliate. I'll leave that in the description of the video. But as always, thanks for watching. We'll see you in the next one.